if a material only goes under one directional loading, for example, think about this piece of rod that is only getting an axial stress sigma, normal stress sigma, then we can calculate the amount of stress that is coming from the load. I said this is the load, and then we can calculate how much stress is caused by the load, and then we can compare that with the allowable stress for this particular material. Now the allowable, we can get it by using the yield strength by some factor of safety. We could also use the ultimate strength by some factor of safety, and then the material goes over that limit, we say it's gonna fail. Same thing we do for the shear stress. So if the shear stress coming from the load, it goes beyond the allowable shear stress, then we say it will fail. Now this is for simple situation, if the load is just pure shear, pure normal, just one directional. However, in reality, material goes under all kinds of stress and loading from all different directions. So it can have a stress in the x-axis, can have a stress in the y-axis and z-axis. So what is the combined effect? Now we use Mohr's circle to calculate the combined effect of all of these shear, xz, and then tau, yz. So all of this effect can be combinedly see how much total normal stress is coming from this combined effect. That can be calculated from the Mohr's circle. In Mohr's circle, that total stress is called principal stress. So we can calculate the principal stress or the normal stress from the Mohr's circle. In the next video, I will show you how to calculate, use Mohr's circle to calculate this combined effect of stress. However, what we are discussing here, how material can fail. Now if you remember that stress strain diagram, which looks like for brittle material, it fails right there. So this is for brittle material. Now for the ductile material, on the other hand, it looks quite a bit different. So it goes under plastic deformation. So this is the up to the yield point, and you can see it goes a quite bit of plastic deformation. So just thinking the material, the yield point for the brittle material or the ultimate, is almost kind of the same point for brittle material, and then using that for all kinds of designing, probably not a good idea. So ductile material, for example, is steel is a ductile material. So when you design things with steel, you should consider that it can take quite a good amount of energy even after the yield point. So it has a good amount of plastic deformation. So this guy von Mises, he developed this theory based on the distortion or the amount of energy it can take. The calculation is not that difficult. You get all these stresses from the Mohr's circle and then uses some extra set of equation like here to get this von Mises normal stress and von Mises shear stress, and then you compare that with the material allowable normal stress and material allowable shear stress, and if the value goes over this allowable limit, it will fail. If it doesn't, it will not fail. So in the next video, I will show you how to calculate both both principal stress and shear stress using Mohr's circle, and also the von Mises stress.